Then we give you tutorial about MC340 feedback control system root locus tree design the root locus.
From the problem, find the best step response when apply P-controller to this equation. So this is a P-controller code loop form. First, we define the ascent cascade with gain by set up the numerator and denominator by using convolution, and we define the parameter to the coefficient of this equation in each term. So after that, we want to find the transfer function. So we use the TF command. Then we want to find the gain. We use root locus by using rlocus command to find the gain. So we got this graph. Critically damped is base response. So we got the two gain, which are 0.0718 and 13.9. We have two values. We choose step info command and feedback command to find the base response, and we got this table. Compare between these two values. We focus on the peak. 13.9 have the peak approximately to 1. Although the tipping time of 0.0718 less than the 13.9. So we choose the gain equal to 13.9. We apply to the final transfer function, which is equal to 1. We got this final transfer function.
For the second problem, we find the best step response when we apply the PI controller. This is a closed loop of PI controller. 0 is minus 2.5. There are this term of KPI. We have to rearrange it first. We will got this term. We know that the 0 is minus 2.5, so the term KI over KP is 2.5. And then we set up the transfer function by using the numerator and denominator. For convenience, we use the convolution to multiply the term together. For the numerator, we have to put the two parameters which are coefficient from each term, 1 and 2.5 from this term, 1, 3 and 2 from the numerator of GS. In the same method, we apply the parameter in the denominator. For 1 and 0 is from this 1, 7, 12 from this term from GS which has already multiplied. We have to use EF to make the transfer function. After that, we got the root locus to find the gain of critically damped because we want to find the best response. So we use the R locus. We got this graph, and this graph shows us the two position of the critically damped, which are 0.29 as again for the first position and 34.9 respectively. So we have to compare by using the step info for each gain. We got the three parameters which are setting time, peak and overshoot. You will see that the peak and overshoot has nearly the same value, so it has no significance in it. For the setting time, you will see that the gain of 0.29 is much more than 34.9. So we choose gain of 34.9 for the PI controller. We apply the final transfer function and got this term of polynomial.
After that, we use the command. You can get the all-dot step response, and this line is PI step response when k equal 34.9. Blue dash line is a PI controller when k equal 0.29. Green solid is P controller when k 13.9, and the green dash line is P controller step response when k equal 0.0718, and we choose the solid line.
Bye bye.